Hey everybody. This is gonna be a different kind of video this time because I just want to show you guys a couple things that I've been doing that I've been working on. It's not YouTube video related. It's just like, let me just adjust that. It's not YouTube video related, but it's let me just show you. Okay, so recently I've really gotten into to mathematics and everything. I've really gotten interested in that recently. I just want to show you guys a couple things. So, not that. So, here we have the quadratic formula for rise over run or for slope. So that's m. That's m equals sub y1 over sub y2, and it's over, so m equals y sub 2 minus y sub 1 over y x sub 2 over x sub 1, and then it's xf, so x function over sub y2, and then it's x sub 2 minus x sub 1 over f of x, and then it's h to the right, tx over th. So, yes, that's just that's a bit of, not full quadratic formula for it, but it's part of it. And then here's the chain rule. I don't know. It's gonna be backwards because the camera's mirrored, so it's gonna be backwards. Let me just read it out. So chain rule equals y equals, in brackets, 2x plus 3, close the bracket, cubed, and then it's 2y over ax equals 3, open bracket, 2x t3, close bracket, square, and then it's 2x plus t3, just plus 3 cubed, x2, and then you have some calculus here. So it's f of x equals x cubed minus 5x. Then it's 3 squared over 3 cubed equals 27. You have to subtract that by 5, and you get 22. I know I'm not explaining this very well, but I'm not. I mean, I'm smart, but I'm not a genius or anything like that. Actually, I have some more recent stuff in here. I just gotta find it. So I have some graphing in here. I have a couple number lines. I got some vertex stuff here. If you guys don't know what it means, I'm going to be going to more explanation videos of math because that's pretty interesting. I don't know if you guys can really see that, but it says f of x equals 1x minus 5 inverse 5, and determine its domain, range, and its zeros. So f of x equals a to where the two formulas meet, and the vertex is c equals 1 union 1 union equals to 5 equals just, you have a blank function equals 0, and then I have a little number line here, just down there. I know it's kind of small, but that's the number line there that I use for the formulas. We have 5 over 0 equals vertex x value of function, so it's equals the x value of the open function, which is k. I put a k here, like the letter k, equals k equals to 0, because if you have this gap here in mathematics, if you have this gap, you need to find a derivative, the derivative of your function, and then you also need to find your vertex so that you can fill in that space. So the 5 over 0, sorry, would be that function, that term that I need. So what else do we have here? We have some compact functions here. So we have exponent 2 over 2x plus 4 exponent x equals 5. Then we have individual exponent equals ex equals 0, which is equals to 0 in standard calc term. You have 2x union over plus 4 union 25, and then you just need to move it over. You need to convert it to get square root of 6 squared minus the adjacent over the original calc term, which is 25. So you just need to go 6 squared minus 4 over 25, and it's the square root. It comes out to 2. And then you have ex equals minus 4 plus square root of 16 minus 4 xa, and then you have equals negative 10. 2xa equals 4. 4x10 plus 18 is 56. ex2 minus 4 plus 21, or square root of 21 over 4 is 4. And you have to reduce it by 2, so that's 2, because you reduce your sum, the term you get from the sum of it, and then you just need to reduce that. And then you go ex equals minus 2 plus square root of 14, and then you just using, let me just alter this, using the Q formula, which is the quadratic. I'm just going to write quad. Let's go write quad form here. That's quadratic formula. So I'm just gonna move my screen like this. That's probably really hard to see, and I'm sorry if it is. In my future videos, I'll try to get a better camera angle. So x, I also have x equals negative 0.138309. So we need to find the initial increase from infinity using the quadratic formula. So all you have to do is plug in 0.138309, which is what you get when you go x over 2 minus 14. So you just need to plug that in to pretty much any pocket calculator. Yeah, some of the information I got from this was like just using like some of the algebraic and some of the calc terms I know, and then I also used a bit of pre-calc, a little bit of pre-calculus calculations. I have a little bear here on the end of my pen. Go cuties. Okay, I used calc functions, pre-calculus functions, and then I also looked into derivatives, and that's just like the story of like how I got to this. So I'm just gonna, let me just up the brightness a little bit. There we go. It's a little bit better. I don't know if it is. Kind of looks the same to me, but whenever I like move my pen, it's like flashes, like it gets brighter. You see that? Yeah, I'm just gonna tone that down. Should I go up? Should I go up or down? Let's go up. Okay. Now, I'm going to just show you guys the basic formula, if I can find it. Yeah, so we have this. This is hard to see, because last night I got bored, so I spent like 3 hours doing derivatives, and then I also looked up a YouTube channel about mainly calculus, and also a little bit of trigonometry on the side. I've already done trig, like I've already finished my trig unit in my math class, so I've already done that, but the calc terms were good because I was able to get the quadratic formula for just devising functions from whatever question you have, because I was able to find derivatives of positives, but then obviously you can't, and I also did some square rooting too. Obviously you can't square 0. You also can't square -1, so I was only able to find like methods of square rooting positive functions and positive terms. We got some, just a little bit of number line calculations here. Right here we have our number line. And then we also have, well, that's more of a slope. It's less of a number line, it's more of a slope form. And then we have our formulas for it that come out to, so first we had x equals 0 equals, so this is the cancel equal sign, so it's like whenever you have 0 in calc, you have to like find things that either add up to over 0 but also under the max number that you found on the other side of the equation, because there's two separate sides to the equation. So I have 0 here, so I was able to find the number that's above 0 but below the maximum number, which is around 2.1, which is what I did for the denominator of this equation. And then I found square root 0 negative 4.1.4 over 2.1, and then you have to just go 2.1 reduce to lowest, sorry, I'm just writing this, reduce to lowest terms, and then you just go equals plus square root of 2.16. That also comes out to 2, around 2 anyway. What is that? There's something on my booklet. Okay. And then we also have x equals fi over 2, which comes out to 2i, which is just 2. Inverse function. And then you also have 9 over r a, which is the runway calc. So since we have some calculus functions here, I'm just going to show you the line here, and I'm also going to label the points. So this is going to be kind of hard to do, but I'm just going to label my points from each of the 4 sides. So that's a 1. I know you guys can't see it, but there's a 1 there. Kind of looks like an S, but I don't know. Writing this is weird. Okay, 2. Just put 3 here. Honestly, it doesn't matter where you put it. I guess it kind of does, because I already have the points established, so I guess it does matter. Yeah. And then you have this. So you have 1 over here, 2 here, 3 here, and then you have the 4th point here. It's mirrored, so 4 is actually here, and 1 is actually here, but it's mirrored, so it's backwards. Yeah, so we have that, and then all you gotta do is just plug that into the quadratic formula. So you go 1, so you just gotta go x function x equals 1 to 2 to 3, establish an exponent, the exponent bracket, to split them up, and then you just do 3 to 4 in another exponent bracket. I know for like all the younger viewers, because I know that most of my viewers are pretty young. Like most of my subscribers are pretty young. Like the subscribers that I do know are my age, like anywhere from like 15 to 16. Which isn't my age. It's just slightly younger. I'm 17. So it's just a little bit younger. So like for anyone that like hates math, which I do, it's just I do hate math, but it's like this part of it, this section of math, like derivatives, trigonometry, slope formula, pre-calc, calculus, advanced calc. It's just interesting. It's weird. It's just interesting. I've never liked these more complex things because I hate algebra, and I think I still hate algebra. But like, it's like mainly calc, pre-calc, calc, and advanced calc that's really interesting, and also derivatives. I spent like an hour and a half, or maybe even 2 hours doing derivatives last night, and then I also moved on, so I pulled a bit of an all-nighter doing some work. Yeah, and like I'm not even like studying any of this in my math class. Like I'm on slope right now in math, so I have like the formula for m, or which is slope. Why do they use m for the letter for slope? Don't ask. I have no idea. So I'm just gonna explain that real quick. So m, I don't know if you guys can see it, but down there we have an m. It looks like a W to you guys because it's mirrored, or it just looks like a back, or it looks like the equal sign is on the right side, even though I put the equal on the left side. So m equals, let me just quickly, you know what, rather than just writing it out, I'm just going to give you guys a slope shape. So we'll go with a 90 degree, just inverted triangle for now. Let's not use that page because there's a used page already. So I've been doing this a lot recently. Slope formula. So I'm pretty, I'm pretty well versed in it, not to brag, but I got it. Just put our theta. Okay, there we go. Now we have the triangle. And this is the slope formula. So just before we do it, slope, anyone doesn't know what slope is? Slope is literally just the direction and distance that a slope moves up relative to how a slope moves vertically to how it moves horizontally. So say you have like a ramp of a high school, like I was doing this recently a couple days ago. You have the wall, but then you also have any railings and anything attached to it that's parallel to it. But the ramp itself, the rise, is your vertical negative or positive distance. You can have a negative slope, which is you're going down, and you can kind of follow the trail of a slope line down to, you can just like follow the trail and see, oh, like if this were to be drawn, I can tell which direction their hand is moving. It's pretty easy to tell between a negative and positive because you can like look at the angle and like the direction that any of the starting points of the line is, like what direction that starting point is facing. It's pretty easy. So m slope is rise over run. So it's the vertical movement, the rise, over the horizontal movement, which is the run. So here we clearly have movement of both rise and run for this. So m is rise over run, or slope is rise over run. Don't ask me like why they picked m for slope. I have no idea. Yeah, so that's the formula that you gotta plug in for your calculation here. It's m equals rise over run. I know it's backwards, so it's annoying. I know my camera quality is not good. Okay, so I'm not really going to go over the numbers themselves for the shape because that's going to take forever, because then you have to like cross multiply, divide. You need Pythagorean theorem. You need trig functions like cosine, tangent, and sine. Again, if you guys don't know what those are, you can just like search them up and try them out for yourself. It's actually kind of interesting, honestly. I have to admit. Trigonometry and slope are both pretty interesting because you use trig functions from trigonometry to solve for slope problems. So now what if we have a straight line? So what if we have I guess rather two straight lines. So I guess what if we have like this? What if we have like a straight line? It's not perfect, I know. What if we have that line like that, but then we also have this? But then we also have this diagonally vertical line. So where's the rise and where's the run? Well, the rise, like I said before, the rise is vertical movement, and as you can tell, just based on the path that the line takes, you can tell that it's going up. You can tell by the way I drew it. You can literally visualize, oh, Malcolm, like, I can tell how Malcolm moved his hand when he was drawing this. It's a positive move, so we're going to put that as M equals P for a positive slope, and that would be its rise because it's a vertical movement. Now, the straight line, so obviously, since we've already established vertical, this second line is the run, right? Well, it is, yes. But here's the thing. We have movement. We have positive vertical movement. We have vertical movement, farting a lot. Anyways, we have vertical movement for the rise line, so this diagonal here. But we have nothing. There's no change in direction with this straight horizontal line. So what does that mean? Well, in slope mathematics, that would be undefined. So undefined is when you have a rise over run ratio, or rise over one, I guess, like, rise over run equation where you have rise is just whatever, it's just whatever number you have for rise, and run is 0. Because run is 0 because if there's no change in the movement, if it's starting at a straight point from end to end, it's straight, then it starts at 0. And if we have a rise movement, even if the line cuts through, like, even if it cuts through the straight line, and you have a vertical going through it, which is what we have here. As you can tell, the vertical line goes through the straight line. That doesn't change the coordinates of the horizontal line. So that's 0. So that would be undefined. Now, what if we have a line like this? What if we have a straight line here? Sorry, no. Let me do that again. So what if we have this, and then say we have this? We have like an X shape. So what's the rise over run here? Well, what you have to do is you have to slightly rotate it. So what I like to do is I establish the formula first. So M equals rise over run. Let's just do rise is, given length, this is about a 62. What units do you guys want? Because I don't have an established angle here. I do have an established angle. We have established lines here, but I mean, like, we don't have established units. Like, I didn't talk about the units. Let's just say hypothetically the unit is centimeters. So, given this length here, I know it's really small, and it's like you don't believe that it's a 62, but it's around a 62 centimeter move, at least for the longer of the two lines. So we have a 62 centimeter movement for the rise, so 62 centimeters for the rise. Now my writing's very small. It's just my writing has improved massively ever since I've started writing math formulas after school. It really helped with like my writing skills. So my writing's been a lot better. So I'm starting to write like way smaller, like 4 times smaller. Usually my thing takes like up a quarter of the page for like one sentence, and then it's like divvying off. It's like either going up or down. Anyways, yeah, so we have 62 centimeters to the rise. Now, what about the run? So I know what you're thinking. Malcolm, there's no run because they're both vertical. Technically, you're not wrong. Technically, you're not wrong. But even if I said that if we have a straight line, it's undefined. But I never said that it has to be a straight line in order for it to be a run line. Because depending on how you look at it, so which line is vertical here? Sorry, stupid question. So let's just I'm just gonna draw this better. So let's do that, and then that. How about that? How's that looking? It's kind of a T sort of shape, lowercase t sort of shape. It's the line is higher than the T. Okay, and then let's just, to make it a little bit easier, let's just put some barricade bracket here. Sorry, barricade bracket is just when you close a trig line to make it easier to look at. Yeah, it's just to make it easier on the eyes. There we go, that's a little bit better. Okay, now we have, so let's just write the formula once again. M equals rise over run. And then you have a rise of, okay, that's like a, that's not even 20, that's like a 15 centimeter rise. So let's say that, yeah, it's around 15 centimeters. This little T thing, 15 cm. So that's the rise. Now what about the run? So the run is, you see I put like a little curvy line here. That's our little H line there. H for horizontal. I'm just going to make that longer because we already have the vertical line, and even though I put the bracket there, the bracket has nothing to do with, like the shape I did. It's not really a bracket, but like the shape I did, like the rectangular thing here, it has nothing to do with the vertical or the horizontal. That's just to make it easier for me to keep the line from going, to keep it from going out of control. It's weird. It's like a cognitive thing. Anyways, it's so 15 centimeter rise. Our run, it's not straight. Okay, it starts out straight, but then it curves downwards. So if you look, see, our line kind of starts a little bit straight. It's a little bit slopey even at the beginning, but then it has a steep decline. So that's a negative slope. So we're just going to put M equals run, comma, N for a negative run, a negative horizontal movement. And this is about, like I said, if it's straight, it's a 0. But if you were to take ever heard of like the unit staircase? Let me just give you a unit staircase here. So a unit staircase is when you're doing unit conversions. It's a staircase of things, and it counts how many steps you do. It's a similar thing with this, except it's not conversion of units, obviously. But it's it's like the inspiration for step part. Like I count the steps down from wherever I started. I know I explained that really weird. Yeah, so I like to do some lines here to count the steps. So this is about starting from the start of the horizontal, which is right up here. It's about a 4-step jump down. And like I said, if it's a straight run line, it starts at 0. So if we're going down a negative slope of 4, that would obviously give you a ratio of 15 over negative 4, because 15 centimeters was our rise, negative 4 centimeters was our run, with a -4 decline, a 4 decline in our horizontal line here, which started at 0, went down by 4. Now, what else do I want to show you? I do have something else here. I have lots of stuff in here. Like, this is 2 days worth of math. Like, I've never written these many formulas at once. But I did have one that I was really impressed that I was able to do. I just can't remember. Oh yeah, this one. This is what's called the derivative operate. So up there it says 2 over 2x. So 2 over 2x is this circled area here, 2 over 2x. I know it looks like a plus sign, but it's an X, I assure you. Yeah, so this circled section here, this is the derivative operant. If you want to know what a derivative is, it's complicated. I don't want to explain it. I'm just here to explain formulas. So you can Google what a derivative is. I'm not telling you that this is the only way you can do it, because unlike science, which is literally just like one solution for most things, at least from what I've known from experience I've done in science, math is different. Math is you have multiple different ways of doing this. I'm not making you guys do this. I'm not going to ask you guys to like pause the video and solve a question. Like, I'm not like the 2010s math antics channels that go, oh, pause the video and you can answer this question for yourself. No, I don't do that. Not to insult those math channels. Like, Math Antics was great in grade 6 when I was trying to figure out long division. I'm not great at math, as I've mentioned before. So long division was not my strong suit. Even now, I'm like, okay, I'm okay with it, but like, I'm not well versed in math. But when it comes to things like calculus and derivatives, I'm pretty good at it, which is funny how I struggle with like less complicated formulas but I'm good with like calc and derivatives. It's crazy. Yeah, so this is gonna be a really long video. This video is already 31 minutes long. Can't believe I've been talking about math for the past half hour. Yeah, it's totally cool though. Like, just to take a break from math for a minute. If you guys have been wondering where I've been, I've just been really busy, and some personal things have been happening. Some things have been happening in my life. Like, if you know, you know. And I've just had stuff that I've had to sort out and deal with. So I haven't really had time to make videos. And I'm really glad that I have the time now, with this upcoming weekend. I have today, tomorrow, and then also Sunday to do some math with you guys. And possibly some other things. I'll just have to see where it goes. Yeah, but I assure you guys, in the time that I didn't make videos, I was not gone. Like, if you know what I mean. I was still going. I was still alive and kicking, of course. Like, just don't think about that. Forget about that. Yeah, so even in the time that I wasn't spending away, it wasn't because I didn't want to. It's because I didn't have time. So my schedule's like, ugh. It's crazy, man. Yeah, so I just didn't have time to make videos, but I'm glad that I now have this opportunity over the next 2 days to make some videos for you guys. And there will be a lot more stuff coming in the future. I just haven't had time. Yeah, so back to the math here. So derivative operant is right up here. These circled numbers here, 2 over 2x, and then you have what else do you have here? So we have 2x. We also have 2x over sub y1, which is what this is. It's hard to see, I know, I'm sorry. And then we also have, we have right here, so we have 2x over sub y1, and then we have the kind of the alligator greater or equal to thingy for 2 bracket x, 2 close bracket over 2 of dx, which is derivative function over x, which is your subcalc. You have a 22 equals out to 22. You have 2 plus 2x comes out to equal or greater than 2x in a little parentheses square down here. And then what else? Oh, rate of change. We have some rate of change here. So rate of change, so we have, just as a basic quadratic starter here, this is like pre-calc stuff, but it's also like intermediate calc. 2 over 2x close bracket x over h, close the bracket equals hx over ch negative 1. 2x over x4 equals 4x first bracket 4 negative 1, 2 negative 1, close bracket, a equals 4x, 4 to x cubed. And then you have a rate of change of f to x plus h, and you have negative your calc function, just your x function here, x in brackets, over h, which is your h value, which is your missing value. Then you just have to go 2x plus h squared plus 2x equals 2x. And then you have x equals 7 to 2 over 7, or 7 to 2 bracket 7. And you have 14 is the rate of change, just relativistic to a doubled value of your base rate. Your base rate is 7 to 2. Your base rate ratio is 7 to 2. And then for rate of change, you just need to find what is that change in relativity to your 7 to 2 ratio, which is a 2 times increase, giving me 14. God, I dropped my bear thing. There we go. I just dropped the thing that was on my pen. Just put it back on. There we go. And we have rate of change. What else do I want to show you guys? Oh, yes. This. So we have... Oh, yes, this. Funny. Okay, we have... Oh, yeah, here's the quadratic equation. Here we go. So we have f of x equals 3x. 3x over 2 plus 1 is this first circled area at the top here. And you have plus x equals x. Then y equals 3x over 2 plus x. I know a lot of x's, so it's g bracket x2 squared. And then you have h to t equals your rule, which is f to x equals 3x squared, plus 1. And then you have your input and your output value. So your input value is f of x, and your output value is your 3x plus 1, your 3x cubed plus 1. So I know that's really hard to see, but it's down here. And then this little circled section is your input and output value. And then domain and range, let's talk about that. So obviously you have your domain and your range. So your domain is your input relative to the formula above it, relative to the numbers in the formula above it. So you have your f of x squared is your input value, and your range is your output value relative to your input value, which is your output range, which would just be f of x cubed to 3 bracket 2 cubed plus 1. I actually didn't finish that question. Okay, so it's around a positive 3. So it's bracket 2 bracket equals 3 bracket 2 close bracket cubed, so 2 cubed. Just order of operations, use your brackets first. So that's 2 cubed plus 3. Obviously, 2 plus 3 is 5. But you have a squared number here because you have a 2 above your brackets. So that's 5 squared. Just using your basic, your basic order of operations, or BEDMAS, which is brackets, exponents, division, multiplication, addition, subtraction. That's what Canadians call it. We call it BEDMAS. Americans, I know a smaller percentage of my people, my viewers are from the US, and actually majority of you are actually from the UK. And then I have about a 12 to 15% ratio for people in the US. I have about a 75 to 80% for UK, and for UK, and then the rest of it is my viewers that are Canadian, so that are in Canada. They're viewing it from Canada, which is where I am, obviously. So I would count in that percentage of viewers in Canada because I'm Canadian, and I watch my videos kind of sort of. I know that's weird, but like... Okay, now we have a domain and range for another quadratic line here. So we have a line formula, which is 2 to 13. Here we have established x and y points for our number line here, and then we also have a upward incline just to establish my x value here, because I can't put x down here because of how math letter function works. I can't put x at the bottom. It has to be at the top because it's first. You always label your x first and then your y afterwards, but then your y comes out to like the bottom here. So it's 2 to 13. That's your domain ratio. And then your range is just whatever is relative to that when you plug it in. When you plug it into the quadratic formula, or just when you plug it into any base calc formula here. So you go 2, bracket 2, comma 13, close the bracket. Sorry about that. Where's my pen? There it is. What was I saying? Oh, I was plugging it in. So it's bracket 2 to 13, 2 comma 13. Close your bracket. You just have to add your y value, which is relativistic to your x, just using the function for when you have a incline that intersect at a parallel point. Because here, you look, here you have this center line. I have 2 points established. I have my left and my right lines here. I have these 2 lines established as the parallel points. It's just they're opposite parallel. So it means that they're parallel to each other. They're just on opposite sides of the incline. So you do that, plug it in, and then you just have it relative to whatever your first half of your formula was, which was 2 comma 13. But it's not exactly the same, because when you use something within brackets in calc, you have a chance of it canceling if you have both numbers being exactly the same. So we can't do 2 comma 13. We need to do 2 other numbers that are either just a few digits lower or higher, but they have to be in the same range that the 2 points that I put here won't change if I were to redo the graph. So if I were to redraw this, if I go too low or too high with my numbers on the right side of my formula, that's going to change how this incline is represented. So it's going to change width, and it's also going to change position. And it'll also change the length of the line that I have below this, which is like a four direction arrow, like I have 4 lines connected in the center, and then I have this 4 directions, obviously, and we have 4 different arrows here. Let me just show you. See, we have this attached to the incline. So if I were to go too low or too high with my digits on the second half or the left side of my formula, that would change the incline. So just as a baseline, let's say like a 5 to 18 ratio is just high enough to alter the points, but not to alter the incline itself. Because I don't want to change the incline, I want to change the points so that I can get the left half of my formula. Yeah, I know this video is lost. This is the last thing I can do before I stop the video, and then you guys will see this. Again, I'm not well versed in math. I'm decent at this stuff, but I can explain it to like a baseline, like grade 12 level, quote unquote, because I'm not grade 12. Yeah, so 5 over 18, that's just high enough that our points can move relative to each other and can go slightly higher on the incline without completely, like, throwing, like, any logistical calc out the window. So about a 5, let's just put bracket 5, comma 18, close bracket, and that is around your baseline that you need. That's pretty much the minimum, that's pretty much the minimum and the max that you can go to. Like, your minimum is like 4 to 16, which is like it's a 2-number jump. It's a 2-number jump and then a 1-number jump. And then, but your 5 to your 18 is about your max because you don't want to change the incline. You just want to alter where the points are positioned on the incline itself. You don't want to change the incline itself. You just merely want to change where the coordinates on that incline are. But you want to keep the incline itself the same, you know? Yeah, so we have F, open bracket, Y, close bracket plus G over R of X, which is just your radiant. So we just quickly put your radiant. You could also put it like PR for percent radiant, because usually your radiant is in like just X percentage, like whatever percentage that comes out to, that's most likely going to be, not most likely, that is indefinitely, obviously, it's maths, it's like, it's not most likely, it's just what's logical and what actually makes sense mathematically. So yeah, so your PR, your percent radiant, you can also do PG for like percent grade if you want, but that's like a whole other discussion. That's like slope formula, early slope formula for percent grade. But you can also do, I guess you could kind of do radiant grade, but like probably not, because that just contradicts what each one is. The percent, your radiant and your grade, like, it's not the same thing. You can still do your percent radiant and your equal radiant. You just can't do a radiant grade because they don't go together. But you can do percent radiant. You just can't do radiant grade. But for percent radiant, you just have X percentage, so whatever percent it comes out to. And yeah, I wish this is an easier way I could explain this, but there isn't. Yeah. I have lots of math written down. And I will probably put some pictures out in my community tab about some other math stuff later on as I continue to put things in my notebook, because this is basically my math notebook now. Not for homework, but it's not for my school. It's just, I got this on my birthday, and I've just been using it for math. So I've got like a couple dozen pages worth of math here that I would love to share with you guys. Hopefully this video does better than my other ones. I think it's pretty good. I'm confident that there are a lot of math lovers out there that will enjoy a bare bones explanation from a 17-year-old. So, yeah, with that, like, subscribe, and I will see you guys in the next one. Yeah, so just go to my community post the next couple of days. I will put out some stuff, some pictures of some of the other formulas that I'm gonna research and come up with. Like research and then jot down. I'm gonna do some calculations for that in the next couple days. Probably start tomorrow, and also on Sunday I'll put up pictures. I'll also do other, probably videos of like other math concepts that I want to explain. I might do like a base addition, subtraction, multiplication, division for like second grade math, like addition, subtraction, division, and multiplication, just for like the really young people that are just like confused on that. And then I also might do some short and long form, like some short form division. I will not do long division because I hate long division. But I will do some short form order of operations. I'll do some short form addition, subtraction, division, and multiplication. And I might even like do some explanations of brackets and exponents, and also your order of operations and what order you have to do, just based on how the abbreviation is structured, like BEDMAS. Like, I'll explain like what order you got to do based on how BEDMAS looks. So yeah, like, subscribe, and I'll see you guys in the next one.